2. Acids, bases, and salts. You are watching YouTube channel at ncert.digital. You have learned in your previous classes that the sour and bitter tastes of food are due to acids and bases, respectively, present in them. If someone in the family is suffering from a problem of acidity after overeating, which of the following would you suggest is a remedy? Lemon juice, vinegar, or baking soda solution? Which property did you think of while choosing the remedy? Surely you must have used your knowledge about the ability of acids and bases to nullify each other's effect. Recall how we tested sour and bitter substances without tasting them. You already know that acids are sour in taste and change the color of blue litmus to red, whereas bases are bitter and change the color of the red litmus to blue. Litmus is a natural indicator. Turmeric is another such indicator. Have you noticed that a stain of curry on a white cloth becomes reddish-brown when soap, which is basic in nature, is scrubbed on it? It turns yellow again when the cloth is washed with plenty of water. You can also use synthetic indicators such as methyl orange and phenolphthalein to test for acids and bases. In this chapter, we will study the reactions of acids and bases, how acids and bases cancel out each other's effects, and many more interesting things that we use and see in our day-to-day life. Do you know? Litmus solution is a purple dye, which is extracted from lichen, a plant belonging to the division Thallophyta, and is commonly used as an indicator. When the litmus solution is neither acidic nor basic, its color is purple. There are many other natural materials like red cabbage leaves, turmeric, colored petals of some flowers such as hydrangea, petunia, and geranium, which indicate the presence of acid or base in a solution. These are called acid-base indicators or sometimes simply indicators. You have been provided with 3 test tubes. One of them contains distilled water and the other 2 contain an acidic solution and a basic solution, respectively. If you are given only red litmus paper, how will you identify the contents of each test tube? 2.1 Understanding the chemical properties of acids and bases. 2.1.1 Acids and bases in the laboratory. Activity 2.1 Collect the following solutions from the science laboratory: hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3, acetic acid, CH3COOH, sodium hydroxide, NaOH, calcium hydroxide, CaOH2, potassium hydroxide, KOH, magnesium hydroxide, MgOH2, and ammonium hydroxide, NH4OH. Put a drop of each of the above solutions on a watch glass one by one and test with a drop of the indicators shown in Table 2.1. What change in color did you observe with red litmus, blue litmus, phenolphthalein, and methyl orange solutions for each of the solutions taken? Tabulate your observations in Table 2.1. Table 2.1. Solution: red litmus solution, blue litmus solution, phenolphthalein solution, methyl orange solution. These indicators tell us whether a substance is acidic or basic by change in color. There are some substances whose odor changes in acidic or basic media. These are called olfactory indicators. Let us try out some of these indicators. Activity 2.2 Take some finely chopped onions in a plastic bag along with some strips of clean cloth. Tie up the bag tightly and leave overnight in the fridge. The cloth strips can now be used to test for acids and bases. Take 2 of these cloth strips and check their odor. Keep them on a clean surface and put a few drops of dilute HCl solution on one strip and a few drops of dilute NaOH solution on the other.